All right, now let's start using our calculator and start doing some things with these matrices. So first of all, if we're going to add or subtract matrices, they have to have the same dimensions. So if I have a 3 by 2 and I want to add or subtract, I have to have another 3 by 2. Otherwise, it doesn't work. And to add or subtract the matrices, you just add or subtract the corresponding entries, and we'll see that. So normally, if we're going to do adding and subtracting, we probably don't even need our calculator for this case. And we'll take a look at a few examples why I would mean that. So for example, right here, if I wanted to add these two, instead of typing these in my calculator and having it compute it, I could just do this mentally. So if I'm adding, it's a 2 by 3 to a 2 by 3, so my answer is going to be a 2 by 3. And all I do is I just add the corresponding parts. So 3 plus 1, 4, right? So then I got 6 plus negative 6, 0. 1 plus 2, 3. 0 plus 3, 4 plus negative 1, and lastly, negative 2 plus 5. There we go, done. Okay, so as long as they're the same dimensions, I just do whatever the operation says in the middle, either add or subtract, and just do it to the corresponding parts. The same thing works with subtraction. Okay, just have to be careful with the signs. So for example, now I got a 3 by 2, and I'm adding it to a 3, or subtracting to a 3 by 2. So I'm going to have a 3 by 2 for an answer. So now I'm going to take 3 minus 4. Well, that's negative 1. So there, maybe, might want to have a calculator in hand just in case. It gets kind of tricky. 4 minus 8. Well, negative 4. Negative 1 minus 6. Or you got to think of that as negative 1 plus negative 6 as well. Same thing. That would be negative 7. So some of you are very good with this mentally, and some, might need that calculator to check. That's okay. So negative 2 minus negative 1, which is really plus 1. So that'd be negative 1. 0 minus 3, negative 3. And lastly, 7 minus negative 12, which is really plus 12, so 19. Okay, so just be careful with the subtraction. That's kind of my best advice when you do these. But I wouldn't recommend typing this all into a calculator and having to do the operations of the matrices. Just a lot of extra work. What about when there's variables? Well, you just list the variables. So for example, I got a 2 by 2 adding to a 2 by 2. So I'm going to have a 2 by 2. Well, I got 3 plus a, which I can't add, so I'm just going to write 3 plus a in the top left. And then 0 plus negative 4, and negative 8 plus 5, and x plus 2. So x plus 2. So I'm just leaving the variable in that case. And how about this? Uh-oh, take a look. I got a 2 by 2, and I'm trying to add it to a 2 by 3. Would that work? No, impossible, not possible. So I cannot add these two together. Okay, so they have to be the exact same dimensions in order to add or subtract them. Scalar multiplication, it's basically just taking a matrix and having a number out front. And it reminds me of the distributive property. So a scalar is just one number that's going to get multiplied, like distributed basically, to the whole matrix. So for example, something like this. This 3 is out front. That's its scalar. And what it means is I'm going to take everything times 3. So 3 times 5, keep it in the top left. 3 times 2, keep it in the top right. 3 times negative 4, bottom left. And 3 times 0, 0. Okay, so you're just really distributing that 3, and it's out front. So it means multiplication. Okay, that's what that scalar means. And if I just did one more, I'll just quickly go through this. So I'm multiplying it to a 2 by 3, so I'm going to end up with a 2 by 3. So 2 times negative 4, which is negative 8. 2 times negative 3, negative 2 times negative 3, which is positive 6. Negative 2 times y, which is negative 2y. So you just leave the variable, just like we normally would. And times 0 is 0, negative 2 times x, negative 2x. And lastly, negative 2 times negative 15 is positive 30. Okay, so scalar multiplication, just really distributing. And like I said, you can do these on the calculator, but it's much faster to do them mentally. But let's practice one of these anyway. Let's just do one of the easier ones. So let's just go back and let's grab this scalar multiplication one here. And let's see if I can get this to compute, just so we can get some practice at how this works. All right, so remember, if I'm going to type in this matrix right here, this 5, 2, negative 4, 0, I need to go into my matrix option, so second matrix. And I'm going to just use matrix A, so I'm going to go over and edit. So remember, when you're going to type it in, you got to go to edit. And I'm typing in a 2 by 2. All right, and so then I got 5 in the top left, 2 in the top right, negative 4, and 0. So that's matrix A. And what I'm doing is I'm taking 3 times matrix A. So I got to say 3 times, and now I need to grab that matrix A. So second matrix, and now under my names is where I grab it. So times A. Hit enter, and there we go. 15, 6, negative 12, 0. It worked out. Good. So like I said, I wouldn't do it in that case. It's a little bit easier to do it mentally. But when you get something like this, where we're going to multiply matrices together, it gets trickier. So I got 3 matrices, and what I'm going to do is I'm going to try to multiply these matrices together. So for example, like if I did A times B right away, I'm just going to write this down low. So that means I'm going to take 1, 3, 2, 4, and I'm multiplying it by 1, 2, 3, 4, 5, 6. Okay, so when they're right next together, it means they're being multiplied. Well, does it look like it should be possible to do that? Some of you might think, well, they're not the same dimensions. Well, let's just test it. Let's try it on our calculator, and then we'll look at it, how it actually computes it mathematically. So first of all, I'm going to go into my matrices, and I'm going to edit all these bad boys. So for A, here's A. I'm going to type that in. So it's a 2 by 2, and 1, 2, 3, 4. Okay, that's good. Go back in. Now I'm going to edit matrix B. And this is a 2 by 3, right? Rows by columns. 1, 2, 3, 4. Lovely. And lastly, matrix C. Go to edit, matrix C. And now this is a 3 by 2. There we go. Okay. So I got them all typed in. Matrix, so I got a 2 by 2, 2 by 3, and a 3 by 2. Perfect. All right. So what I'm going to do is that I'm going to grab matrix A, and I'm going to multiply it by matrix B. Oh my gosh, it worked. So it took a 2 by 2 and it multiplied it to a 2 by 3. Interesting. So that worked. Okay, so I'm just going to write that down, what that was. So 9, 12, 15, 19, 26, 33. Weird, okay. Well, let's try A times C now. Let's see what that does. So second matrix, grab an A, and I'm going to multiply it. Second matrix, grab a matrix A, and I'm going to multiply it by matrix C. So second matrix C. I could just hit 3 as well to grab it. C and enter. Uh-oh, dimension mismatch. So this did not work. A times C did not work. So I'm going to cross this guy out. So it didn't do A times C, but it did do A times B. So in order to figure this out, we have to discuss what's actually occurring here. So the reason why I did A times B, and I got these written right here, how it's going to work is it almost distributes in a way. It's kind of tricky, but what it does is it takes one of the rows, so it starts with the first row, and it's going to like multiply it by the first column in order to get this number. And how it does that is this right here. So it takes the 1 and it multiplies it by the 1 up here. So it takes the first one times that first column. So it takes 1 times 1, and it's going to add it to 2 times 4. Hence, 1 plus 8, which is 9. See how that works? Well, then it's going to do the next one. It's going to take your 1 times 2 again, or your 1 and 2, and it's going to take it to the next column. And you notice how this row matches the amount in this column, like there's 2 in this row and 2 in each column. So rows need to match columns when multiplying matrices. Okay, so rows need to match the columns when multiplying matrices, because what's going to happen next is it's going to go for the next spot 1 times 2, right? It's going to take the first one in the first row and the first one in the second column, and then it'll take 2 times 5 and add that. 2 times 5, which we get 2 plus 10, which is 12. And then it'll do the last one. It'll take that 1 and 2 again and go to the third column. So it'll take 1 times 3 plus 2 times 6. And we got 3 plus 12, which is 15. So you see how that's working? So then if it went through the next one, now it's going to deal all with the second row. So it's going to go 3 times, well, now it's going back to the first column again. So 3 times 1 plus 4 times 4, and then it'll go 3 times 2 plus 4 times 5, right, because it took 3 times 2 and then 4 times 5. Just kind of takes that row and matches it with the column. And then lastly, it's going to take 3 times 3 plus 4 times 6. So that's what is occurring when they multiply matrices. So kind of confusing, a little bit tricky. So let's just kind of look through and see which ones would work and which ones would not. Okay, so if I did B times C, remember I got to look at the rows. So how many are in the row? So B has 3 in the row, and C has how many in the column? There's 3 in the column. So it could take these 3 and match them up with these 3, correct? Yeah, so this would work. That's good. What about B times A? So now it's going to try to take these 3 and match it up with this column. Well, A times B worked, but would B times A? Because whatever comes first, it takes the row and tries to match it up to that column to multiply and add. Let's just try it. What if I did the opposite here? Yeah, it doesn't work, okay? So it's not commutative. So this guy worked, but this guy did not. Okay, so it always starts, whatever the first one is, it takes that row and multiplies it into each column. So they got to match the amount in each row has to match the amount in each column. What about C times A? So C's got 2, and it's got to match with 2, so that would work. C times B, 2, and it's going to match with 2 into the column, so that would work. So hopefully we're starting to get the gist of this. So the row number in the row has to match the number in the column, like going first to second. So A times A. Well, that seems like it should work, right? Because you're taking 2, and then you're going to multiply it into the column of that first one. Let's just try it. Let's see what we get when I take A times A. Yeah, so that works. So you should be able to multiply. So all these should work as well. So good, 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 good. All right, very good. So the number in the rows has to match the number in the columns in order to multiply two matrices. And in this case, this is where I would actually type them in and multiply them on your calculator. It makes it a little bit easier. So if I try to do this, I got a 1 by 3, and I'm multiplying it to a 3 by 2. So there's 3 here in this row, and there's 3 in this column. So does that work out? Sure. Yeah. That should work out. So if I did this, I'm going to do this one mentally here, or without a calculator. So I'm going to have 2 times 4, and I'm going to add that to x times 0, which is 0, and I'm going to add that to 5 times 3. And then I'll take this row again and do the same thing to the next column. So that would be this next spot up top here. So I'm going to have 2 times 1 plus x times x plus 5 times 1. Okay, so that's going to be the top 2 spots. So if I rewrote this down here, I would have 8 plus 0 plus 15, which is 23. And if I added these guys, I'd have 2 plus x squared plus 5. So that would be x squared plus 7, right? Because 2 plus 5 is 7. So hopefully you got the gist of that. So we just got some variables, which will make it a little bit trickier. And then would I do anything else? No, because I already did this row times this column. So that's it. So it just multiplies into a 1 by 2. So that would be my answer right there. So that works out. So you just got to make sure that the number in the rows matches the number in the columns in order to multiply. And lastly, if I wanted to multiply by a matrix to get the exact same matrix. So for example, I have 3, 4, negative 5, 2, and I multiply it by some matrix, and I want it to stay the exact same. we have something that we're going to use quite a bit, and this is called the multiplicative identity. And that matrix is made up of this, 1, 0, 0, 1. Okay, and we're going to use that guy once we actually solve our systems of equations with matrices as well. And this could be the case for, that's for a 2 by 2. Well, if it gets bigger, if it's a 3 by 3, basically the ones are all in the diagonals, and everything else is 0. That's kind of the main thing. So this is the multiplicative identity for a 3 by 3, a 4 by 4, so on and so forth. So they all have to be kind of like a boxed matrix in a way for it to work out. But we'll use that more coming up.